Hello and welcome to today's webinar, the exciting new features in nRF Connect SDK version 2.4.0 that was released just a few days ago. I'm your host for today. My name is Tiago Montt, and I am a developer marketing manager here at Nordic Semiconductor. A few practicalities before we get started with the webinar. The duration will be about 50 minutes, followed by 10 minutes Q&A section. We encourage you to ask questions, but please type your questions on the top right sidebar. And all questions are anonymous, but of course, try to keep them relevant to the topic in today's webinar. We'll answer those questions towards the end during the Q&A. There's also a chat that you'll find on the bottom right sidebar. The chat is not anonymous, and it should not be used for questions, but feel free to exchange messages with the other webinar attendees. If we're not able to answer your question during the Q&A, or if you still have questions after the webinar, then we recommend that you go to DevZone and ask your questions there to get the answers. And then after the webinar, there will be a recording made available together with the presentation at webinars.nordicsemi.com/on-demand. And moving on to the agenda, we'll start with an introduction to the nRF Connect SDK. Then we'll talk about updates on our development tools, including a demo. We'll have updates on our PMIC, so that stands for Power Management IC, if this is a new term that you haven't seen before. Then we'll have updates on security, updates on Bluetooth, Wi-Fi, Matter, and Thread, and we'll wrap up the webinar with updates on Amazon Sidewalk. So one of our missions here at Nordic is to excite and support developers, and we do it through various ways. So we have the webinars that serve mostly as technology introductions and trainings. Then, of course, we have the DevZone, as mentioned in the practicalities. That is our tech support center and also online community of developers working with Nordic products. On our GitHub, there's a large collection of repositories in various programming languages and projects that you can use to get started. And then we, of course, also have the Dev Academy, which is an interactive online learning self-paced platform where you can find courses on various topics to get you started with developing with Nordic. So let's then have a quick introduction to the nRF Connect SDK. So the nRF Connect is a sort of umbrella term that includes all the software and tools from Nordic Semiconductor. And that, of course, as part of that, we have the nRF Connect SDK. So that has essentially all the embedded software that you will need to build your IoT applications, from the low-level hardware drivers all the way to various samples and applications that demonstrate functionalities within the SDK. Then we have the nRF Connect for desktop. These are various PC tools that serve multiple purposes. For example, the toolchain manager offers one-click install for the SDKs, or the programmer allows you to program the firmware into your target devices. Then we have nRF Connect for VS Code, which is our preferred IDE to work with the nRF Connect SDK. Contains various features to help you develop and debug your application. And we also have a vast portfolio of mobile applications. One of the most popular ones is the nRF Connect for mobile, which is a sort of generic Bluetooth Low Energy application that allows you to discover, connect, and exchange data with Bluetooth LE devices. So the nRF Connect SDK, in a nutshell, is a unified code base and toolchain for all of our devices: the nRF 91, the nRF 70, the nRF 53, 52, and the nRF 21. For the nRF 52 series, it's an optional SDK starting from version 1.3.0. You can still use the nRF 5 SDK, but we highly recommend that you go with the nRF Connect SDK, especially if you're starting a new project. It's a much more future-proof solution, so that is our recommendation. It, of course, includes a variety of wireless stacks to develop your IoT applications, and the Bluetooth host and controller stack are Bluetooth 5.3 qualified. That has been the case since version 2.0.0. And let's then continue with updates on the development tools. So in nRF Connect for VS Code, we have introduced a tool called Device Tree Visual Editor. Well, in fact, this tool was introduced as a pre-release a few months ago as part of the pre-release version of the extension, and it's something we covered in the previous nRF Connect SDK webinar, including a short demo we had there. But now this has been pulled into the production extension, so you don't need to toggle between a pre-release and production version of the extension in order to use the Device Tree Visual Editor. However, I need to highlight that it's still an experimental feature. So do when you use it, be mindful of this, and you can still provide feedback from within the tool itself if you click on that little banner on the top right side of the user interface. So this essentially gives you a visual representation of the device tree, so you can more easily edit all the possible parameters and settings around that. And the benefit is that it will allow you to abstract from the underlying data structure. So you can a little bit accelerate configuring the hardware that you need, so the board that you have that you're going to work with. And one thing to highlight is that you can use it alongside the text editor. So these are not mutually exclusive options. You can edit things on the device tree visual editor, and if you actually have the text editor open, you will see that as you work on this side of the tool, you'll see that the text editor, you'll see those changes live, and the same thing in the other way. So if you're going to make changes on the text editor side, you will see those changes in effect on the GUI immediately. So they can be used alongside each other. And one last thing to highlight is that you can use this with the existing project. So you don't need to start a new project to use this tool. If you have an existing project, when the extension gets updated, you will be able to use the device tree visual editor with your existing device tree files. And now a new tool that was introduced in nRF Connect for Desktop just a few days ago is the cellular monitor. So this allows you to evaluate network communication, modem traces from the cellular devices, from the nRF 9160. And it integrates with Wireshark, so you can load the traces for analysis, and you can also feed them to Wireshark live if you want to do the decoding on the go. It also integrates with the serial terminal, which is a separate application in nRF Connect for Desktop. So it can share the COM port traffic between the two applications, so you can launch commands from either side and also see all the activity on the serial terminal side. To get you started faster, it also includes built-in precompiled samples. That's something that we'll demonstrate in just a second. And right now, this tool is in a preview state, but as it gets more mature over time, it will replace the LTE link monitor and the trace collector. So let's have now a quick demo of this tool. So let's go ahead with our demo of the cellular monitor. And the first thing to highlight is that this tool is currently in a preview mode. So that means that we're still working on the features. And of course, as you use the tool, you might find some small bugs or some instability. The good news is that you can provide feedback within the tool itself, which I'll show you in just a second. So as you use the tool, and of course, we encourage customers to use it as much as you can, whether you're just getting started with cellular or if you're already developing, and provide feedback as you might run into issues along the way. And as mentioned, so eventually, as the tool gets more mature, it will be the replacement for both the LTE link monitor in here, as well as the trace collector. So these two applications will eventually be shown as deprecated within nRF Connect for Desktop. So I'll go ahead and open the cellular monitor preview, make that full screen. So to provide feedback, as mentioned, there's a tab here at the top, feedback, and then you can just write your message and send feedback to our team who is working on the cellular monitor tool, and they will be able to react and make improvements based on your findings. Going back to the dashboard, I have the nRF 9160DK connected to my computer, so I'll go ahead and select that. And the first thing I would like to show is that if you don't have the firmware running on the kit, or if you don't have the correct firmware that has, for example, the modem traces enabled, you can program the firmware directly from the tool. So there's three pre-built applications that can be flashed. The one that I have flashed into my kit is the serial LTE monitor. So you can select either one of these, pressing the select button, and then you can flash the modem or the application firmware. So if you already have the latest modem firmware version running on your device, you can uncheck this box and you'll just flash the application. So it's a little bit faster process. If you don't have the latest modem firmware, then this is also an easy way to get that into your device. And there's also a very handy link to the documentation page for the specific sample that you have selected. So I'll go ahead and close that. And then before getting started with the communication with the target, I'll open the serial terminal. So this is a tool that we introduced a few months ago. It was discussed at the previous nRF Connect SDK 2.3.0 webinar. And this is one of the key reasons why we've developed our own serial terminal is kind of illustrated right here. So the reason is that this allows us to share the COM port data between two applications. So in this case, they are both connecting to COM port 10, which means this is the COM port that's being used for AT commands. And this means that both the cellular monitor on the left-hand side, as well as the serial terminal, will be able to receive and send data from that COM port. So whenever there's activity, it will be shown on both sides, on both applications. So now I can go ahead and start, and you can immediately see that the AT commands that are being sent by the cellular monitor are also showing up on the serial terminal side, as well as the responses that are being received from the device. And so it's so we have our trace is enabled, the SIM card is okay. Now we are connected to the network. Everything seems to be in order. So the first thing that I would like to highlight is here at the bottom side of the tool, there's the packet event viewer. So this is showing traffic on AT commands, RRC, NAS, and IP. And if you want to see some of the details, you can just hover over the specific dot. So each dot represents a packet, and it gives you a little bit more detail on what the packet contains. Then you will find a lot of parameters, a lot of information here on the dashboard. And if you just hover over any of these, you get a tooltip that contains a little bit more information about the specific parameters. You can also, there we go. You can also go to the documentation for that specific command. So that takes you to the info center on the specific command page. And you can also run the command from here. So for example, let's say we wanted to read the email, it's already there, but we can just go here and click run command, and you will see that command also then popping on the serial terminal side. So I'll just go ahead and click run command. And you can see that we sent a command here, and the command, so the email was received. And we can also kind of manually type it. So if I type AT plus CGSN, and you'll see the same thing. You can try this with other commands, for example, operator, run command, and it will update that, or should update that. There we go. Now it says DNA. So as you can see, there's sometimes things are not updating straight away. So there is still some work to be done on the tool. And all these commands that were sent manually, you can also see them here on the packet event viewer. So you see here the latest response from that command that was retrieving the operator name, and this was the command itself, and then the ones for the email that were sent before that. So now I will stop the cellular monitor and disconnect from the kit to show that you can also load trace files. And what this will do is that it will sort of replay the trace. So when I open this, you will see that the packet event viewer will start kind of populating with the traffic. So I'll just go ahead and click open. And this is the trace from what we just did 10 seconds ago. So I'll go ahead and open that, and you can see that the traffic is starting to appear there. We can also open the trace in Wireshark. So I'll just select the same, and this will then be converted into a PCAP file. So I'll click open in Wireshark, and that invokes Wireshark, converts the data, and then we can see it using the decoder on Wireshark. Takes a few seconds to get that loaded up. Okay, so if you remember when we started the cellular monitor traffic, there was a lot of AT commands. So you can see that there's this big green blob here that takes about 2/3 of the The communication are 80 commands, but if we start scrolling down, then we'll see also modem trace activity here, which is labeled differently depending on what kind of packet it is. I'm going to go ahead and close Wireshark. And one thing that I forgot to mention, so I need to connect back to the kit to mention that. You can also open Wireshark and get the traffic fed into Wireshark live. So as you will see the traffic coming here on the packet event viewer and on the serial monitor, you can also have a third application, so Wireshark, where you can decode the traffic in more detail. So this is the cellular monitor. We hope you can find it useful for your development activities around cellular IoT, and again, encourage everyone to go and try it out and to provide feedback if you have suggestions or if you find any issues with the tool. And let's continue now with the PMIC updates. And since this is the first time we're talking about PMICs within the context of the nRF Connect SDK webinar, let's maybe have first a quick overview of the NPM 1300. This is a highly efficient and compact PMIC with the main purpose, the main application being sort of devices which are powered by rechargeable batteries up to 1000 milliamps hour. And this PMIC integrates multiple system management functions that allow you to save components. Like it has ultra-low power and includes a precision fuel gauge, a hard reset feature, watchdog, boot monitor, as well as a power fail interrupt. And if we take a look at the block diagram here on the right-hand side, we can see it contains the charger for the battery, 2 LDOs, 2 buck converters. It also is able to drive 3 LEDs, and it has up to 5 GPIOs. And this can be configured by a host device with the TWI interface, which is I2C compatible. And it comes in a couple packaging options. So within the nRF Connect SDK, we added support for the NPM 1300 as well as the NPM 1300 evaluation kit. So this supports some of those features that I mentioned earlier. So charger, buck converter, LDOs, load switches, and GPIOs. And there are 2 samples that were introduced to demonstrate some of these features. One sample is demonstrating the fuel gauge functionality. So what it does is that it calculates the battery state of charge. It also gives you time to empty or time to full, depending whether the battery is being charged or discharged. And it's providing updates on these parameters over the serial terminal once every second. And there's a second sample, which is providing a shell interface so that you can interact through the shell with the PMIC features. So the bucks, LDOs, load switches, and GPIOs. And now we have a demo that our PMIC team has prepared for us today.
Hi there. I'm going to be discussing our fuel gauge sample for power management ICs. So this sample supports our new NPM 1300 PMIC, which has a battery charger, 2 buck outputs, plus LDOs, load switches, LEDs, and GPIOs. Now this sample can be found in the NCS 2.4 documentation under Samples, PMIC Samples, NPM 1300 fuel gauge. The PMIC needs a host to communicate with, so we'll be using an nRF52DK to provide this. Following the wiring section of the docks will result in the following setup. On the left is the NPM 1300 EK with a battery and USB power supply connected on the left-hand side. The USB connection to the PMIC doesn't have to be to a PC. I'm using a laptop charger for this example. On the right-hand side is the nRF52DK with a USB connection to the PC on the top. This connection is used for flashing and for the terminal interface. The connections between the boards are the TWI interface, that's clock, data and ground. Now we have the hardware set up, we can follow the rest of the sample documentation to build and flash the sample. Once you've used the nRF Connect SDK to do this, open an nRF serial terminal to view the output. The terminal displays the current voltage, current and temperature measurements, together with state of charge, time to empty and time to full. The current value is positive when discharging and negative when charging. In this case, we can see a small discharge current. Time to empty is only calculated if there is a significant discharge current, and time to full is only calculated if the battery is charging.
If I connect a charger, you can see charge current flow and time to full start to be calculated.
And from the PMIC, we go into security updates. So in security, we have added support for Oberon PSA-Core library. So this is a library provided by a third-party company called Oberon Microsystems, and it provides an optimized implementation of the PSA crypto API. So PSA stands for Platform Security Architecture, and it's a global consortium or a global partnership of companies founded by ARM together with a number of security evaluation labs that aims to create a standard approach into IoT security, including a framework as well as a certification program. And key benefits here of this PSA core library, PSA Crypto API implementation, is a smaller flash footprint compared to the Embed TLS PSA Crypto implementation. It also offers an improved or a simplified configuration scheme. And this implementation has obtained PSA certified crypto API status. So how this works in practice, that if you have an application that has cryptography needs, crypto operation needs, it uses the PSA Crypto API to request those cryptographic operations. And then the Oberon PSA core library implementation will use crypto driver APIs. And if there is support on with the acceleration hardware for a given cryptographic operation, it will use the hardware crypto drivers that will then access the underlying hardware crypto acceleration capabilities. And if a certain cryptographic operation is not supported through acceleration, then it will run through a software implementation that just uses a general computational from the CPU to run the crypto operation. And now moving forward with updates on Bluetooth. And first on Bluetooth LE, so we have added support for periodic advertisement with responses. And just a reminder that we introduced the advertiser role in nRF Connect version 2.3.0. And this was introduced as an experimental feature. And now we have support for both advertiser and scan role. So we have the fully featured implementation. And what this feature brings is bidirectional exchange of application data using connectionless communication. So this is not something that was possible before this feature being introduced. You had to, if you wanted bidirectional application data exchange, you would have to use an LE connection. We've also added experimental support for encrypted advertising data. And this feature brings a standardized way of encrypting data in advertising. And this applies to both extended advertising as well as legacy advertising. And it also defines how to share the key material that is required for the data encryption. For this feature, there is also a sample available in the SDK. So you can look at the documentation following this link over here. If you want to know more about these two features, so they were both introduced as part of the Bluetooth 5.4 specification. And we have a blog post on DevZone that goes through a little bit more into the details. And you can also look at the on-demand recording for the nRF Connect SDK version 2.3.0 webinar, where we talk a little bit more about the periodic advertisement with responses feature. All right. So since we've already discussed this one on the previous webinar, we can maybe discuss a little bit more about encrypted advertising data. So as mentioned, this brings a standardized mechanism to encrypt advertising data, and it can use any advertising transport. So, and it's actually quite flexible because you can encrypt the entire advertising payload, or you can encrypt just a subset. And this brings a new AD type, the 3.1 in hex, that encapsulates the encrypted data. So if you look at the diagram up here, it has an example of advertising payload that contains both encrypted and unencrypted data. So on the encrypted data, you will have then the new AD type that encapsulates the encrypted data. So which means that the payload can consist of multiple advertisement data sets that will be encrypted. And that can be sent alongside unencrypted data. So this could be, for example, the flags or the device name that you might want to send out unencrypted, while we have some more sensitive data that you want to send encrypted using this new feature. And then it also adds a get characteristic, encrypted data key material, to exchange that data that can be used to encrypt the data that goes over the advertising. And this new characteristic, it's mandated to be read over unencrypted and authenticated links, so that it's ensure that it's being read securely. Then moving from Bluetooth LE to Bluetooth Mesh, we have added experimental support for Bluetooth Mesh 1.1 features. So those were remote provisioning. So what remote provisioning does is that it allows you to provision devices without having to be within RF range of the provisioner. So this was the existing mechanism in the current Bluetooth Mesh spec. The provision needs to be in range of the devices that it's provisioning. So you need to sort of have a device provisioner that can move around and provision the devices within the range. Then it also brings a device firmware update, DFU, and block transfer modes. And this is to update the firmware of the mesh nodes through the Bluetooth Mesh network. Also, private beacons to improve privacy of secure network beacons. Enhanced provisioning authentication algorithm, also on the security sphere to increase the or improve the security of the provisioning process, and various mesh enhancements to improve some of the performance of the mesh network. And talking a little bit more into detail about two things: remote provisioning, and then after this, DFU. So remote provisioning, sort of to delineate the difference between Mesh 1.0 and now Mesh 1.1. So if you have, for example, a mobile phone that was being used as the provisioner, you would have to be within RF range. So you were provisioning, for example, light bulbs, you would have to be within range, provision those devices, and then you would have to move this within range of other devices that you wanted to provision. And now with the remote provisioning that's being introduced in the Mesh 1.1 specification, you can have a device that is static, like, for example, a gateway, which you can easily move around to be within RF range. And you start by provisioning the devices that are in RF range, and then those devices can use the mesh network to provision other devices which are not in direct range of the provisioner. So this allows for a little bit more scalable solution where you can, for example, if you're deploying, let's say, a lighting system across a commercial building, you could, for example, eventually deploy, install all the lighting systems across the floor, and then have a provisioner that sits in one part of that floor and then can provision the whole system using the mesh network without an operator having to move the provisioner around to be within RF range of all the various devices that it needs to provision. And then on Bluetooth Mesh DFU. So there's a couple different roles here within the DFU model and the process. So the first role is the initiator, and this is the device that checks for available updates for the firmware that's running on the target node. So the target nodes are the devices that have firmware that needs to be updated. And the firmware, could come from, for example, the manufacturer's mobile app, or just download it directly from their website. And the initiator will then transfer the firmware to a device that's called a distributor. And that can be done over a GATT. And actually, in this context, what this means is that it transfers the firmware using a model defined in the specification, or it can also be transferred out of band. And here what this means is that it's transferred using some sort of proprietary mechanism. It can also be over GATT, so over an LE connection, but it would use, for example, a custom GATT service instead of something that is defined in the specification. And then the distributor is the device that delivers the new firmware images to all the target nodes that need to be updated. And it also keeps supervises the whole process of getting the firmware update done across all the target nodes. So it kind of acts as an intermediary on behalf of the initiator, so that the initiator doesn't always need to be present on the mesh network. So if the initiator is, for example, a mobile device, then most likely it will be out of range of the network, and then the distributor will continue. So it's responsible for the whole firmware update procedure while the initiator is not part of the network. These two roles can also be combined. Like, for example, if you have a gateway device, it can be both. So it can be the initiator in the sense that it can retrieve the firmware, for example, from the internet, and it can also do the distribution role and sending it over the advertisement bearer to all the target nodes that need to be updated. So if we would be using a mobile app or mobile phone, this is where the initiator and distribution roles are, more. They're better defined because it's clear why they are split. So the initiator would then get the firmware from the internet, and then it would transfer it to the distributor. In our mobile app, so the mechanism defined in the Bluetooth mesh specification using the firmware distribution client, which we do not support, but we do support the firmware distribution server on the distributor side. So if you would have a mobile app that or some other type of devices as the initiator that supports firmware distribution client, then you would be able to use that mechanism defined in the Bluetooth mesh specification to send the firmware. In our case, we are exchanging sending the firmware from the initiator to the distributor using the SMP client. So the SMP is the simple management protocol that's used also for Bluetooth LE DFU process. Then the distributor, once it gets the firmware, it will use the firmware update client model and the blob transfer client model to send that through the Bluetooth mesh network. So using the advertisement bearer to the target node or target nodes, plural, most likely. There's multiple to be updated, and it supervises the whole process. And then the initiator can also use the firmware update client model to get status updates on the firmware on the status of the firmware update procedure. So once the target nodes have had their firmware updated, then they would have a new firmware version listed, and this is the model that the initiator can use then to retrieve that information from the target nodes and ensure that the firmware procedure has completed successfully. And to wrap up the Bluetooth updates portion, the Bluetooth SIG is also introducing something called Bluetooth Networked Lighting Controls, NLC as an acronym. And what this means is this is Bluetooth profiles for network connected lighting. So this is addressing more of an application level interoperability, and it sets requirements for applications to comply with this new specification. It's based on Bluetooth mesh topology, and it specifies the use of the Bluetooth mesh models required to implement this NLC set of profiles. And they have a webpage that explains this in a little bit more detail. So what we are doing at Nordic is aligning with the NLC by adding new samples and improving existing ones. So in this SDK release, we added a new supported sample, mesh light dimmer and scene selector, and we have also improved the mesh light fixture and the mesh sensor samples so that they align with this specification and these profiles which are needed to be compliant. Now for updates on Wi-Fi. So in this SDK release, we have added support for Wi-Fi station mode on the nRF 5340 host platform. We've also added support for Bluetooth LE coexistence. This was already there in nRF SDK version 2.3.0 as experimental, and there's also a dedicated sample to demonstrate how that can be put in place. And we added support for Wi-Fi on the memfault sample, so that now you can use Wi-Fi for uploading data to the memfault cloud. This sample also existed previously. It was only supported with the cellular, so it was under the nRF 9160 samples, but now it has moved to a new category called debug samples. since now it supports both Wi-Fi and cellular transports. So it can run on the nRF 9160DK or 3091 for the cellular, or you can also run it then with the nRF 7002DK for the Wi-Fi. So it depends on the board that you select. And if you want to learn more about Memfault, we had a webinar late in 2022. So you can go and watch that on demand to learn a little bit more about what they can offer. And to explain a little bit more about the coexistence between the Wi-Fi and short-range 2.4 radios. So the goal of the coexistence solution is to mitigate the interference between the Wi-Fi radio and short-range radios like Bluetooth LE or 802.15.4 radios such as Zigbee or Thread. Like, for example, if the Bluetooth LE radio receives a packet, it's important that the Wi-Fi is not transmitting on the 2.4 gigahertz band. So the nRF 70 series devices has this wireless coexistence control logic that's based on generic packet traffic arbiter design that has various signals. So it has a request signal, status, priority, and grant signals. So it has flexible output signals and also can be 3 or 4 wire interface configuration. So the status and the priority can be separate lines, or it can be just one wire. And so the way it works is that when the PTA receives requests from multi-protocol radio, so from the hosts, it can be a host system that has a short-range radio, or it can be a separate IC. And then it may grant those requests based on the priority or the status properties. So, and this also has some nice benefits because it allows you to implement a design which has a single antenna that can be shared between the two radios. So this allows for a solution where both the size and the cost might be a little bit reduced compared to using two antennas. And if you're interested in our Wi-Fi solution, I recommend that you go and sign up for our Wi-Fi newsletter, so you'll be you can stay up to date on updates on our Wi-Fi solution. And also, we had the webinar when we launched the Wi-Fi Introduction to Low Power Wi-Fi webinar, which you can watch on demand. And now for updates on Matter and Thread. So starting with Matter, we have added support for the Matter 1.1 specification that was recently released. If you want to learn a little bit more about that, there's here a link to a CSA blog post that talks about some of the additions that came with the specification. So, but the two things to highlight is that it has enhanced support for intermittently connected devices. So these are commonly known as sleepy devices. And these are your typical, battery powered devices, things like sensors, door locks, switches, and other type of devices that are not connected to a mains power outlet. So what this brings is that there's a reduced likelihood that these battery powered devices will be reported as offline when the users or platforms interact with it. So users, for example, using a mobile app, or platforms meaning, for example, a Matter gateway or a voice assistant that's part of the Matter network. So this now allows developers to better optimize their products, and they can create better user experience around their products. And then the second thing is that this new specification also brings improvements for device makers and developers to get started with Matter, and also to more easily certify their products. And last thing to highlight in terms of Matter updates is that Matter over Wi-Fi solution that has been moved out of experimental and is now supported in the nRF Connect SDK version 2.4.0. And now for a new topic related to Thread. So Nordic has joined the KNX Association, which means that as of today, developers are able to evaluate KNX IoT technology. And they can build prototypes of KNX IoT products using Nordic's multi-award-winning system-on-chips, multi-protocol system-on-chips, and nRF Connect SDK. So for those who might not be familiar with KNX, we can give now a brief overview. So KNX is an open standard, and it's mainly deployed in commercial and residential building automation. So commercial buildings would be things like office buildings, airports, shopping centers, these types of buildings. And it's popular especially with HVAC control. HVAC stands for heating, ventilation, and air conditioning. So in these commercial buildings, but it can also manage other types of devices like lighting applications, blinds, shutters, security systems, and many others. KNX is most commonly deployed and installed as a wired infrastructure using a twisted pair medium that can be in a tree, a line, or star topology. But there are some other options. So on the terms of physical communication media, there's also power line. Then we have RF option, FSK modulation in 868 megahertz band, so sub-gigahertz band. But there are also some IP links available. Now, KNX IoT or KNX IoT Point API. This is a new addition to the options of KNX physical transport medium. So now the transmission medium is IPv6, and the goal here is that it future-proofs KNX. It allows it to be used with all kinds of IT equipment and other common IP physical transports. And KNX IoT standard is backed by an open source software stack. And the software stack has been sponsored by the KNX Association, and that's available online on this link over here. So KNX IoT was developed in a way that it can work with common IP physical transports, and one of those transports is Thread. So this new open source software stack can be used on top of Thread, which is a low power IPv6 based wireless standard. So what does this mean that you can now use KNX IoT with Thread? So this actually brings quite good benefits to KNX, because currently the KNX RF is limited to Europe. So it's not a deployment that can be made globally. It does not support IP, and it also does not support mesh topology. On the other hand, the KNX IP transport is not low power. So this transport is meant more as a baseline for building infrastructure like a network backbone, and not as a transport, so something you directly connect for a sensor, an actuator, or other types of devices, especially battery power devices. So this is where KNX IoT over Thread becomes interesting, because it is a global solution. So it runs on the 2.4 gigahertz ISM band, and it's also low power, so it enables that feature, and it's IPv6 based mesh networking. So which means that now you can have battery operated KNX IoT sensors lasting for years, instead of if you were to connect them with the KNX Net IP, then you would be looking at months of battery life, which is quite reduced, and something that would require very often to be maintained, which is not something that you want, especially in commercial and residential buildings. So KNX IoT brings great potential if you're retrofitting an office building, because you don't have to install the wires. So the cost of adding a sensor or another device using KNX IoT, when compared to the twisted pair medium, which would imply you need to lay out the wiring, can be 10 times lower. So there's great potential there to create KNX IoT networks. So our KNX IoT solution at Nordic, so as you know, OpenThread is based on IPv6, and it doesn't have a defined application layer, which means that other application layers can run on top of Thread. So one of the most, one of the examples is Matter. It runs on top of Thread, but there's also HomeKit, Google Weave was another one, and then we have KNX IoT. So because Thread is application layer agnostic, it can support many IP-enabled application protocols. So Nordic has been working with Thread for many years, so we've used our expertise to enable another application layer running on top of Thread. So this KNX IoT open source stack has been integrated with the nRF Connect SDK. It is available on GitHub through this link over here. And as of now, the support is experimental. It's meant for evaluation and development. This is not a production-ready implementation. And it also requires that you integrate it with the nRF Connect version 2.3.0. And now for the last topic in today's webinar, we're going to talk about Amazon Sidewalk. So for those who are not familiar with Amazon Sidewalk, it's described as a sort of a community network, and it uses Amazon Sidewalk bridges. And these would be things like Echo devices or Ring devices to provide cloud connectivity between IoT devices and the cloud. So this is operated by Amazon, and it has no charge for customers. Some of the key benefits here are streamlining access to cloud. So this means that users get sort of enhanced reliability in connecting their devices to the cloud because they can eliminate the need for any sort of proprietary gateways or mobile apps. And the other thing is that Amazon Sidewalk also provides automatic setup or onboarding and registration of devices. So essentially, when you buy the Sidewalk device and you take it out of the box, it will automatically connect to the cloud. Then also asset tracking and finding lost items. And the reasoning here is that the Sidewalk devices can connect to any bridge device, not just the bridge devices that you have in your home, which means that it provides asset tracking in the sense that knowing which device your asset or your item is connected to will provide you some sort of localization where the asset might be located. And the other one is in providing connectivity. So as mentioned, that the Sidewalk devices can connect to any kind of Sidewalk bridge. So they provide connectivity beyond the range of the Wi-Fi in your network. So it provides longer range at a little bit lower data rates, but it's a network that's kind of designed to be between your home and the range of cellular networks. So neighboring gateways can provide redundancy in terms of network coverage. And one thing to mention is that Sidewalk is currently only available in the US. And there are two variants of Sidewalk. First one is Sidewalk over Bluetooth LE. So this offers the shorter range variant, which is mainly targeting applications within the home. But it's also the option that provides the highest throughput. And then we have Sidewalk over sub-gigahertz that provides longer range, sort of beyond the gate connectivity or neighborhood connectivity, but without incurring the cost of using a cellular network connection. But of course, with longer range, there's always a trade-off. In this case, is throughput. But within sub-gigahertz, there's Sidewalk over FSK and Sidewalk over LoRa. So LoRa offers the longest range, but it has the lowest throughput. And FSK is a little bit lower or shorter range than LoRa, but still longer range than Bluetooth LE and a little bit higher throughput than LoRa. So the difference, again, the trade-off is between range and throughput. And all of these variants will be able to connect to a Sidewalk bridge, which will then connect to the cloud backend. So Amazon Sidewalk, how it fits with the nRF Connect SDK. So it is integrated with the nRF Connect SDK. So it can use our qualified Bluetooth 5.3 protocol stack for the Bluetooth LE connectivity option, or then there's also the option to use sub-gigahertz with an external device from Semtech. So Semtech sub-gigahertz radio transceivers, and there's a library integration there that you can use. We support multi-protocol operation, Bluetooth and Semtech's sub-gigahertz radio. And similar to the KNX that we discussed earlier, this is distributed as an nRF Connect SDK add-on, which you can obtain separately directly from GitHub. And it also requires nRF Connect version 2.3.0. And going into some of the samples that are part of this nRF Connect Sidewalk SDK package. So there are template samples, and there's actually two of them, one for Bluetooth LE and one for sub-gigahertz. So they provide sort of template application to develop Sidewalk endnotes. And the idea of these templates is that you can create a secure communication channel between the end device and the AWS IoT core for Amazon Sidewalk. That will, of course, go through a Sidewalk gateway. And the second sample is sensor monitoring. So this is demonstrating a bit more of a tangible use case. So it demonstrates how you can monitor sensors, in this case temperature, as well as actuator control. So you can control IDs and get control of the buttons over the Sidewalk network. So there's an application server, sort of a cloud backend with a web UI that you see here on the right-hand side, which is compatible with the sample. And this is provided by Amazon. So our Sidewalk R&D team has actually prepared a demo for us, demonstrating how this sample works. So we're going to go and see that demo now.
To demonstrate Nordic Sidewalk enabled device, I will use sensor monitoring application available in Nordic SDK Sidewalk. This is an application that demonstrates a set of simple Sidewalk-based IoT use cases, sensor monitoring, command control, and alerts. The sample application communicates with the cloud backend over the secure Sidewalk network. nRF 52840DK is used as Sidewalk Edge device. It communicates with Amazon Echo Gateway using BLE or sub-gigahertz LoRa or FSK protocols. Gateway routes Sidewalk messages from Edge device to the Amazon AWS Cloud backend with Web UI via secure Sidewalk network. The step-by-step instruction how to set up complete Sidewalk environments, deploy cloud backend, and provision Edge devices can be found in Nordic SDK Sidewalk documentation. The nRF 52840DK has been flashed with sensor monitoring application and device-specific binaries. After boot, Edge device registrates itself in Sidewalk network and starts sending the temperature measurement periodically to the backend. We can see here Edge device works over BLE. The backend visual the data on the graphic UI in form of chart and button icons. A user can engage button on the Edge device, which is reflected as button icon in the web UI. This is an uplink communication. A user can toggle LED buttons in the UI view, which is then propagated to corresponding LEDs in the Edge device. This is downlink communication.
And that's it. We've reached the end of our webinar for today. We encourage you to sign up for more webinars at webinars.nordicsemi.com. If you want to learn more, we have interactive online courses at the Academy, at the Dev Academy at academy.nordicsemi.com. If you need tech support, you can obtain that through the DevZone at devzone.nordicsemi.com. And if you just want more general information about our products and services, you can find that at our corporate website, nordicsemi.com. And now let's move on to the Q&A, where we can answer some of the questions you've been posting during the webinar. All right, thank you everyone who attended today. So we had a few questions coming in, and we're also going to answer some questions from yesterday's session where we couldn't have the Q&A due to some technical challenges. So I'll put them all together and answer them now in this session. So starting with a few questions on the new Bluetooth mesh features. So the question was, what would the upgrade path be for a mesh product using the previous available DFU method with the SMP? Could a firmware update be designed keeping the same bootloader and transition to mesh DFU? So the answer is that, yeah, the bootloader is still MCU boot. So yeah, SMP is built as part of the application, and using the previous DFU, then the new image would have the firmware update server, which is the implementation of Bluetooth mesh DFU, which then replaces the SMP. So, and both the solutions will be using the MCU boot as the bootloader. Then still on Bluetooth mesh, there was a question: does distributor require dedicated flash for storing the image when working as a distributor, or can it reference an image it has already updated itself with? Yeah, so the answer is that yes, it requires dedicated flash for storing the image. So currently we don't have support for the case where the distributor sort of references its own image for distribution. And then there was a question on KNX. Why is KNX not using Bluetooth mesh as transport instead of thread? And the key thing is that the KNX IoT in this case is meant to run on top of IP, and Bluetooth Mesh does not support IP. That's why it's running on top of Thread and not on top of Bluetooth Mesh. And then there was a question about signing up for the Wi-Fi newsletter. So you'll find a link to the slides when we make the recording available, perhaps still today, but most likely on Monday. And then on the slides, you'll find the link there. And then will there be support for AP mode on the nRF 7002? There will be support for soft AP, not full AP. And soft AP, the difference is that soft AP is the main case is for Wi-Fi onboarding. So if you have a device and you don't have Bluetooth LE for onboarding or commissioning, then soft AP is the mechanism to do this, where you send the device will allow you to connect, for example, with a mobile phone, and then you can send the SSID and password for the network that you want to connect to. So it's meant for onboarding. And then a few questions on the PMICs. Does the PMIC provide battery protection circuitry? So this actually varies a lot from battery to battery, and it's very uncommon to find raw batteries without their own protection circuitry built in. So most batteries will have this built in already. It's not something you put on the PMIC side because of the variation on the battery. And then does the PMIC also protect the battery from draining completely? It protects from over discharge. So when the battery voltage drops below 2.3 volts, the NPM 1300 will shut down, which should also help protecting from the battery draining fully. What is the purpose of the NPM 1300 GPIOs? Well, it's just a flexibility feature added to the PMIC that can be used as required by your application. If you're, for example, have a small host and you run out of GPIOs, then you can leverage the PMIC GPIOs as a complement. So you don't need to buy a larger package on your host device, for example. But it's really mostly application dependent. And then news on support for electronic shelf label profile. So this is something that customers can build today on top of the host features that we discussed during the webinar. So on top of periodic advertisement responses and encrypted advertising data. This is, essentially a get profile and the specification is available. So it's something customers can create by themselves. And on our side, providing support for this out of the box, this is a roadmap item, and that's not information that we tend to discuss on the webinars. And then one more question now on Sidewalk. Can the nRF 5340 support Sidewalk? So currently the support is using the nRF 52840, and this has to do with the Amazon Sidewalk certification process with Amazon. It is possible to use the 5340, and to this we would ask you to reach out to your regional sales manager from Nordic. You can find the contact form on our website and tell them that you want to use a different part, and then they can start the discussion, because it has to be discussed directly with Amazon as well. Let me check if we had more questions coming in. Any sneak preview or information about nRF 54? So yeah, if you go to our website, the nRF 54 product page has all the latest information, and that's all that we are giving out publicly at this point. And when will NPM 1300 be released? This is also a roadmap. It's coming soon, but for a second, I'd give an exact date when that will happen. And I think this was the last question. Let me see just if anything came in the meantime. No, so I think we've tackled all the questions. Thank you all who attended the webinar today, and we hope to see you again for our next Nordic webinar. Thank you.